I'd like to do a quick rundown of a typical problem for this week. It is going to tie in a lot of different skills in terms of basically finding slope from all these different representations. And so sometimes we're given an equation, sometimes we're given a table, sometimes we're given a graph, and sometimes we're just given a story situation, and we've got to be able to determine how fast is the story changing, whatever it is that's changing in the story. This particular story is one about these 4 health clubs, and they are charging a certain amount of money in a total cost, and there's some sort of a charge per month. And that's really what we want to determine so that we can compare all 4 of these health clubs. And so when I start a problem like this and they ask me to make a decision, make a choice, this is an application of what we're really looking for. We're looking for the rate of change, but the reason that we're doing this is so that we can make a good choice for ourselves and we can save some money. So the first thing that I do is I start by looking at the situation that I feel most comfortable with. You all have different amounts of experience from your middle schools, and you, at some point or another, calculated rates of change or slope. I'm here just to sort of remind you about how we do that. Now, in our previous video that I showed you this past weekend leading into our Monday class, I gave you a couple of examples of the way that we calculate slope from a graph. And so I'm going to go relatively quickly through that because you can watch my previous video. What we determined here is we want to know how much, first of all, how much this line went up. And I think I'll just full stop. Let's think about that. It started down here, and when I'm measuring where this point is that I'm drawing at the bottom of this height of a triangle that I'm about to create, we call this a slope triangle. Boy, that's a mess. The height of that is measured up and down. And so when I want to measure up and down, I go over to this ruler. This y-axis is just a ruler for helping me to measure how high any point is on a graph. And this point right now is high. This is at $40. That's how high that point is. This side of this triangle that shows how much the line is increasing, we call that the rise, how much it's going up, goes from 40 up to 70. Well, let's think about this. If I had a 70-year-old person and I had a 40-year-old person, how much older is the 70-year-old compared to the 40-year-old? Well, we wouldn't count 41, 42, 43. That's just going to take so long. But what we know is when we're looking for the difference, we can do that by subtracting. And so here, this rise, this amount that it changed, is the 70 minus 40. Going back to that story that I said, the 70-year-old is 30 years older than the 40-year-old. This went up. Between those 2 points, the difference is 30. Now, we can do the same thing down here because remember, when we're calculating our rate of change or our slope, we know how much it went up. How long did it take? Well, I mean, this one you can probably count 1, 2. But again, we could also use that same strategy just to show you that it works. That 3 minus 1, how far did we go? How much older is a 3-year-old compared to a 1-year-old? Well, 3 minus 1 is 2. So now we have the 2 parts that we need in order to calculate the slope. But remember, a slope is a fraction. The slope is a fraction that tells us basically how much it's going up divided by how much it's going over. We call that the rise divided by the run. So this is going to be 30 minus 2, or $15 per month. We can go to a table. Now, because we've done this work using a graph, we can think of it the same sort of way. We want to know how much more money did we have to pay, and how much did we divide, or how long did we get to divide that over? Well, it took 1 month to go up $21. And again, really what this is the rise over here on the Y's, and the run over here on the other one. I made a rhyme there. So again, my slope, or my rate of change, we call it sometimes, my slope is going to be my rise over my rise over run. So it went up by 21 for every 1 month. So now I just know, okay, $21 for each month. This is $21 per 1 month, per month. Now we can go to our story situation. Well, here we actually have a pretty easy situation. We know that they told us that it's $20 for Health Club D each month. $20 per month. And this one we just have to read carefully in the story situation. This one has a different starting point. This one starts at $20, but the rate of change here that the Health Club D is charging is $20 per month. And then our last one comes from our equation. Now, here we're going to need a little bit more experience, and we'll be developing this throughout the week, but I hope that you've at least seen some equations that look like that. And if you have, well, then you know that this number here is called the slope number, and this is the y-intercept number here. Okay, so the number that we want in this story situation is just going to be that number that's with the x. That's going to be our slope in our slope-intercept form. Y equals mx plus b. Y equals mx plus b, which you probably have seen at least once or twice in middle school, and we'll certainly be digging into that more, and I'll be teaching you more about that. If you didn't know that, though, you could certainly say, well, if x is the months and y is the cost, well, what happens if we do 1 month? Well, if I put 1 month in there, for 1 month, this would be 12 times 1 plus 60. So for 1 month, this would be, what's that? 12 plus 60 is 72. 72. For 2 months, well, that would be 12 times 2, because we're just putting it into this equation where the x is, and then plus 60. So that's 24 plus 60. That would be 84. So for 2 months, 84. And then we could go back to what we did on the table, and we could say, oh, well, that went up by 12. When the month went up by 1. And so again, our slope would just be 12 over 1. So now we just have to collect all of those slopes and bring them back to the problem to make a decision about which of the health clubs had the lowest rate. So here, Health Club A is 12. So I'm going to go here and just write 12. Health Club B, well, that's on this one. That was our table. Oh, B was 21, so I'm going to go here and write that's 21. And then C, we found out was $15 per month. So C was $15 per month. And then D was $20 per month. And I really should be putting these units all the way in there. So this is per month, and this is per month, and this is per month, and this is per month. And so which representation has the greatest rate of change? Well, Health Club B had a rate of 21.